Okay, I think it just started automatically. So 1.7 takes a while. It takes us 4 days. So make sure in Google Slides that you're splitting it up and you're making 4 separate slides. Last night's was, two-sided, so that would be 2 slides. Front side on one, back side on the other slide. So 2 slides for 1.7a. Now we're doing 1.7a day 2. So then tonight's is going to be a 2-sided worksheet as well. So keep that in mind when you have to duplicate slides on your Google slide, okay? All right, so here is some basics, some properties. Let's talk about properties. It's been a long time. Let A, B, and C be real numbers. Okay, the addition property. And that is super small. Okay. If A equals B, then A plus C, like what I'm doing, if I know that A equals B, then I can add this C to both sides. So I just added C to both sides, which I can totally do. I can add 5 to both sides of an equation. I can add 29 to both sides of an equation. Okay, so that's good. Subtraction property, I can subtract the same thing, okay? A lot of people might call it the addition property of equality, the subtraction property of equality. Whatever I do to one side, I have to do to the other. And that's what that means, property of equality, okay? So then, subtraction property of equality, I subtract the same thing from both sides. Right? I want to go through, no. Good. Multiplication property of equality. I can multiply the same thing by both sides. Multiply C. Okay? It's like, how about this? How about if I have 5 equals 5. Well, couldn't I also then say 5 times 3 equals 5 times 3? I can multiply both sides by 3 if I want. So that's what we're talking about. Division property of equality. I can divide as long as there's not a 0 involved, okay? Like if I'm trying to divide both sides by 0, I need to just, zeros are not involved. Substitution. Okay, if I know that x equals 7, then I can say, I could say 5x equals 5x, 5 times 7 equals 5 times 7. I can substitute in, instead of an x, I can replace it. A lot of people like to put it in parentheses to substitute. That's fine too. Okay. So now what I'm going to do is I'm going to do 2 problems where I actually have to solve. I have to solve something out, okay? So I'm going to do this. I'm going to do 5x minus 18 equals 3x plus 2. So this statement is what we're told. So since we're told it is given to us, I write the word given. Now let's talk about what's the next thing that we would do. What would you guys get the x's together? Would you guys get the 2 and the 18 together? What would you do first? Tessa.
Subtract 3 to both sides.
Three x, right?
3x.
So here's what I'm going to get, guys. I'm going to subtract 3x to both sides. I'm going to get 2x minus 18 equals 2. It's the subtraction. Sometimes we like to abbreviate, guys. Some subtraction prop of equality. All right, Samantha, what are you going to do next? I've heard from you guys. Here's who I need to hear from today, or you get no participation this week. Adam, Simra, William, Sayla, Jacqueline, Johan, Antonella, Armando. Okay. Can I hear from one of those?
Oh.
Simra, go ahead.
You would use the subtraction property again and move the add 18.
So if I'm going to add 18.
Oh, addition property.
Addition property, yep. 2x equals 20. Addition property of equality. Good. Jacqueline, what am I going to do last?
You divide 2 on both sides, which is x equals 10.
I do. What was the reason for that? What are you going to say? What property did I just use?
Equality.
The what?
Division property. Of
Yes.
equality. Good.
So we're basically just like taking the steps to find x, but we're basically doing it step by step and labeling everything we do.
Because once upon a time, 6th grade, 7th grade, something like that, you had a teacher that went through each step and they may have actually told you these words. Hey, you're supposed to, this is the property we're using. Or maybe you didn't. I'm not sure. Just depends on how good your teacher was, right? But these are the real reasons why you solve an equation, in case you guys didn't know. Okay, next, let's do number 2. All right, so algebra. 3x plus 4 equals 2/5 x. If you've already volunteered, I prefer not to hear from you today, guys. Because there's people, like 5 people that still have to get their participation in. Really? Oh, yay! Sayla.
The first step is given.
Yep. Perfect. Always, pretty much always, guys, the first step is given. Adam.
You multiply 5 to both sides.
Oh, that'd be fine to do. I don't mind doing that at all. Because he wants to clear the fraction. He wants to get rid of the fraction. A lot of people would subtract 3x. $15x plus 20 equals 2x. Multiplication, property of equality. Good. Okay, love it. Antonella.
You subtract 15x.
Yep. 2 minus 15, negative 13x, I guess. Yeah. Subtraction property of equality. All right. Armando.
You would divide negative 13 by both sides.
True, true. 20 divided by 13 equals x. It's a fraction answer. Division property of equality. Good. Okay. Those are algebra properties that you saw up above. Now I'm going to talk to you about properties of equality and congruence. These are things that you're going to need to memorize. We're going to use them a lot. They get used a lot. Reflexive. When I look in the mirror, I see my reflection, right? The reflexive property means that one thing equals itself. Mrs. Grant equals Mrs. Grant. A equals A. The measure of segment AB equals the measure of segment AB. Okay? So there's that. Reflexive. Reflection. Okay? Symmetric properties. Symmetry, right? Symmetric. So if AB equals CD, then CD equals AB. So I'm basically, symmetry means that I can like switch the ordering and they still mean the same thing. If measure of angle B equals the measure of angle A, then measure of angle A equals the measure of angle B. I just switch the ordering, but it's symmetry, okay? Congruence. If segment AB is congruent to segment CD, then just switch the order. Segment CD is congruent to segment AB, so I just switch the ordering around. Measure of angle A equals B, the measure of angle B equals A. Okay? So that's nice. Switching the order. So that's what I'll put for symmetry. Reflexive, I'll put that the same equals the same. Transitive property. Okay. If AB equals CD and CD equals EF, then AB equals EF. Okay, we did this in logic. If I'm friends with Reese and Reese is friends with Simra, then I'm friends with Simra. You like skip over the middleman. Remember we talked about that? If I'm friends with Reese and Reese is friends with Simra, then I'm going to be friends with Simra. You're like, well, maybe you're really not friends with Simra. You might not have ever met Simra. But it's kind of like, if I like Brussels sprouts and Michael likes Brussels sprouts, then I like Michael. Is that true though? I don't know. Like, so sometimes this works, but it is a property. So in geometry, we can say it because it's usually regarding to like the size of an angle or how long something is. So then I can use it. But when you think about real life situations in the transitive property, it really isn't very relatable. If AB, it's like PQR, remember? Remember that? So, if angle A is the same as angle B, and angle B is the same as angle C, then I can jump to the conclusion that A equals C. okay? And the same thing with congruence. If a segment is congruent to a segment and this segment is congruent to that segment, then I can jump and skip the middleman that AB is congruent to EF. Okay. Segment addition postulate. And my copy got cut off because I'm at the bottom of the page trying to squeeze it in. A, B, and B, C makes up the whole thing AC. This chunk, AB plus BC, makes up the whole thing. Segment addition postulate. Okay. If ABP, if this angle plus this angle, if they're added together, they make up the whole thing. They make up the whole thing, which makes sense. If I add a little chunk and another little chunk, then it's the whole angle. I don't know if I can do that right. If I add this chunk and I add this chunk, this angle plus this angle, then it's really hard to put your finger down. It equals the whole thing. Kind of weird. I can't do it with my hands. Okay. Also, a whole angle can be broken up into two parts, right? Top part, bottom part. This piece of angle plus this piece of angle makes the whole thing. That's what angle addition postulate is about. Okay? So now we're going to practice this with some geometry. Okay. The measure of angle ABC is DEF. Okay. The measure of angle ABC is congruent to DEF. That means they're the same size. So now, since they're the same size, here's what I'm going to say. Oh, I'm also told, measure of angle 1. So you need to mark it up. You need to get a pencil or pen and you need to mark up what we're told. Because as we go through these, you're going to want to see what was true 2 steps ago. Measure of angle 1 is equal to the measure of angle 3. They have the same size angle measure. So on number 1, these 2 things right here, I was told up above in the given. So for number 1, I'm going to put given. Okay. Now I'm going to do number 2, and I'm going to say, okay, measure of angle ABC, this whole giant angle equals 1 plus 2. So the whole angle equals this part added to this part. And that's kind of logical if you think about it. The whole thing equals 1 plus 2. So any thoughts on what I might say? Because it's right here. It's something here. This whole angle is made up of this little part plus this little part. Adam.
Sorry, I didn't even have a hand up.
Oh, sorry. Aaron.
Angle addition postulate.
Yep, I am adding up 1 plus 2 to make the whole thing. I'm adding up 1 plus 2 to make the whole thing. Angle addition postulate. Now, DEF is made up of 3 plus 4. Very similar. Johan,
It's the angle addition postulate.
same thing. I'm adding up two angles to make one big one. Now, okay, this one I'll get to explain to you. Angle 1 plus 2 is equal to 3 plus 4. This angle added to this angle equals 3 plus 4. So, check this out. I was told way at the beginning, let me explain this. I was told way at the beginning that this whole angle ABC is equal to DEF. So ABC equals DEF. So for ABC, I'm going to say 1 plus 2. This is the same as ABC. Isn't it? Isn't ABC the same as 1 plus 2?
Yes.
Yes.
3 plus 4. Isn't it the same as DEF?
Yes.
Yes.
So
Yes.
instead of saying ABC, I said 1 plus 2. Because look, I substituted. Okay. So now I'm going to say three plus 2. If I added these two, 3 plus 2, it would be the same as if I did 3 plus 4, because isn't 2 the same as 3? Like, I'm sorry. When I add them up, angle 3 plus angle 2 is equal to 3 plus 4. Because 2 and 4 are the same. We're trying to prove that 2 and 4 are the same. So you're basically looking and seeing what happened from one step to the other step. From 4 to 5, what did I do? These is all the same. The thing that I changed is I said that 1 plus 2 and then 3 plus 2. But look, these angle 2's are the same, right? So Shay, what are you going to say? Or what are you thinking?
Is it symmetric property?
Symmetric would just be reordering it. The problem is that this is the same, this is the same, this is what's different. Instead of the 1, I put a 3. But look up here, 1 is the same as 3. So you always look and say from the step before to the next step, what did I do? I didn't change this at all. I didn't change angle 2 at all. I changed, instead of 1, I replaced it with a 3 because 1 is the same as 3. Instead of 1, I replaced it with 3 because 1 is the same as 3. That's again substitution. Substitution. Okay. Now, let's look from 5 to 6. I was at step 5. What did I do to get to 6? Well, angle 2 is congruent to angle 4. I had angle 2 up here and I had angle 4 up here. The only thing I did was take out the measure of angle 3. I took it out from both sides. I took out the angle 3 from the left and I took out the angle 3 from the right. What is it called when I take out something from both sides? Taking something out from the both sides.
Deletion.
Aryan. You raise your hand. Go ahead.
Yeah, isn't it the subtraction?
Subtraction property of equality. Subtraction property of equality. Very good. Okay. I'm going to fit in one more. I only have time to do one more, number 4. Okay. Given that this whole segment AC is equal to BD. AC equals BD. AC equals BD. I'm told that. That means they're the same size. So write that on your first line. And it's given. All right. Now, I'm going to have to guide you and kind of lead you and do a lot of this for you so you can kind of see how it's done. But AC is this segment, and AC is made up of 2 parts. So the next logical thing for me to do is to break up those 2 parts and talk about them like this. AB plus BC equals AC. Also, like the 2 parts make the whole. AB, this chunk plus this chunk makes the whole thing. Then I can say BD. So I'm basically breaking up one long segment and I'm putting it into 2 parts. Okay, BD. BC plus CD. BC plus CD makes up the whole thing. BC, so you're going to have to write small, plus CD equals the whole thing, BD. This was segment addition postulate. I gave you 2 parts and I said they're equal to the whole. Segment addition postulate. Okay. All right, here we go. Next thing I'm going to do, because remember, I'm trying to prove that this little piece, AB, is equal to CD. So I've got this so far. I'm just going to redraw it because I think it'll help. AB plus BC. I should go to C, shouldn't I? And then CD. Okay, my goal is to prove that this piece, sorry, is the same as this piece, right? I kind of, if you notice it too, you kind of just need to get rid of this BC because they look like they're the same size. So the next thing to talk about is that the middle piece equals itself. And this is new, you've never seen this before. BC equals BC. The segment in the middle equals itself. Reflexive. Okay. All right, stay with me. Because this first time is like me just kind of talking you through it. Now, don't I know that AC and BD are the same? I was told that at the very beginning. So then I can say that they're parts. are equal. Since I know that these two guys are the same, let me do a different color. Right? Wasn't I told that they're the same? So now, can't I say that my purples are the same? Because that's what makes up AC. This is what makes up AC. This is what makes up BD. So if I, instead of saying AC equals BD, I'm going to put that they're parts. Here's AC. And I'll even write it on top, really small. AC equals BD. I'm basically saying it again. That's called substitution. Okay. And the last step is, if I want to get AB equal to CD, these greens, I basically have to remove this guy right here. Let's do green again, because that's what we're talking about. I've got to remove this BC out of it. If I want to say that AB equals CD, I got to get rid of that BC. So I'm taking it out from both sides. When you take something out from both sides, subtraction property of equality. Okay, subtraction property of equality. So this is called a proof. And we're going to go through it, and I'm going to hold your hand the entire time because we're online. It's not as easy to comprehend when we're doing it online. I can't be there to like look at your papers and to be there in person to make it easier for you. So you're not doing number 6. But you do have the task to do the homework, which is pretty easy on the front side and pretty easy on the back side. You're going to need this to look at, these properties here, this one and this one. Okay, I made your homework easier. You do not have any geometric proofs on your homework tonight, okay? All right. Okay, so upload your homework, work on it. You're practicing a lot of these here, solving for X kind of thing, and then you do a couple of algebra proofs where you have to say whatever these properties are. All right, you guys have a 3-day weekend right now. All right, let me stop recording, sorry. Okay.